Hello. In this video, we'll be talking about consistent PLS-SEM, also denoted as PLS-C, which essentially mimics factor modeling that we have in CB-SEM. Okay, let's take a look at what we want to do here. Consistent PLS or PLS-C algorithm performs a correction for reflective constructs correlation to make result consistent with the factor model, which essentially means we want to do within PLS-SEM we want to do modeling like CB-SEM, and we know the CB-SEM is a covariance based structural equation modeling, while PLS-SEM is a variance based structural equation modeling. And CB-SEM is recommended for confirmatory modeling, such as theory testing, model testing, while PLS-SEM is recommended for theory building and exploratory studies, as well as predictive causal modeling. So what do we do? If without using CB-SEM, we want to create similar analysis. We want to do similar analysis as CB-SEM. Within PLS-SEM, we can use PLS-C, consistent PLS-SEM. Just to make it clear, PLS-C mimics the modeling of CB-SEM, which essentially means PLS-C is able to provide us analysis using common factor like CB-SEM does. Okay, so just like CB-SEM, PLS-C is recommended only for reflective constructs in a model, and we know that when we have reflective plus formative constructs, we use PLS-SEM. Okay, so let's go straight to Smart PLS. Okay, so excuse me. So I have my model here. My model has three independent variable: communication, benefit, and perceived value, and then commitment as my mediator, and then cooperation as dependent variable. Okay, and all of these my constructs are reflective, and that means my model qualifies to be tested using PLS-C, which is consistent PLS-SEM in Smart PLS. So let's go straight to. Okay, so just like regular PLS-SEM, we will be doing consistent PLS in two parts. First, we'll be assessing our measurement model, and then we'll be checking our structure model. Okay, so this is where you see the consistent PLS algorithm in Smart PLS. Let's click here. Let's go straight to. Just make sure you have this area check. Connect all LVs for initial calculation. Partial least square. Okay, and the difference between, since we will be using common factor, so we should be clicking here on factor for the measurement model only. Okay, and then click start calculation. Okay, so we're done. So first thing first, we want to go straight to our outer loadings, and looks like our outer loadings are a little bit problematic when it comes to communication. 0.5 and 3, 2 of the item for value as well. However, before we make any change, looks like we have a little problem here as well. Let's have a look at our reliability and average variance. Okay, so definitely we have some issue with perceived value, because recommended threshold is that it should be 0.5 and above. However, it's 0.48. Okay, so one option I have is here that I may go here and identify those low factor loading and remove them, and then see if that helps me improve my overall average variance, because rest of the Cronbach alpha, row, composite reliability, all those are perfect. It's just the issue is with perceived value. So like I said, the one option is that I may go back here and remove one of those low factor loadings such as this one, and see if that improves. Just for the sake of this video, we'll assume that our values are for AV values for all of our construct is 0.5 and above, and if you see that it's pretty close to 0.5. Okay, for the sake of this video, we'll just move on. Let's check the other measurements. Okay, so it looks like our discriminant validity according to formula criteria also looks pretty okay. Next is Inertia Statistics Vif, inner VIF. Again, none of VIF value is as high as 3.3. So it looks like our VIF, we don't have multi-collinearity issue. And then last is model fit. Well, it's important to mention here that in consistent PLS-SEM, just like CB-SEM, just like we do in Amos, we should report model fit. And the area, we have two types in Smart PLS. We have saturated and estimated model. We should be focusing on estimated model. And essentially, there are two criterion that I'm specifically interested in is SRMR and NFI. Okay, and let's go back to our okay. So according to the criteria, according to SRMR rather, it should be below 0.08, and NFI should be above 0.90. So let's take a look at how is it doing in our model. Okay, SRMR is 0.052. So okay. And then we have NFI 0.868. So it looks like we definitely have problem with NFI. Okay, and again, I would do the same thing. If any of my items can be removed, probably I want to do that. Or other way around is that I may wanna have a couple of more items, a couple of more connections here. Okay, so let's run. Let's run. Okay, let's see if I improves. Modifate. Oh, it's 0.869. Oh, nonetheless, it remains problematic. So let me remove this here. This extra path. This is not what we had originally hypothesized. Okay, consistent PLS, and then okay, rest looks okay. Okay, so assuming that our NFI and SRMR are okay, just for the sake of this video, I'll move on and I'll run a structural model. Okay, so this is where I'll be doing my consistent PLS bootstrapping. Now here where we do the regular PLS-SEM. So consistent PLS algorithm is different, and for this we go here, consistent PLS bootstrapping. Okay, and again here I should be checking for the consistent PLS bootstrapping. I should be checking path, now factor. The rest looks okay, and just run it. I'm sorry, it's going to take. Okay, so here we have our structural model results. Looks like we have all path significant except for this one, where perceived values effect on commitment is insignificant. Let's take a look at our specific indirect effect, and again the path between perceived value and cooperation through commitment seems to be insignificant. The rest of the path are significant. Okay, that's about it. Just to highlight again, in PLS, consistent PLS, we are actually mimicking the result, mimicking the analysis that we do in CB-SEM, and we only do it when we have only reflective model in our reflective construct in our model. That's about it. Thank you.